All right, what's going on, everybody? This is Cool Coder, and today I'm looking at LeetCode 33, search and rotated sorted array. So in this problem, we are given an input array, and this input array is possibly sorted. So what possibly sorted means is that, so for this example, it's rotated at the index 3. So at the index 3, all that means is everything on the right is going to swap with everything on the left. So if you look here, everything on the left, 0, 1, and 2 is on the right, and everything on the right, 4 through 7, is going to be on the left. So that's what rotated means. So in this rotated array, they want us to find a integer target. And we want to return the index of the target if it exists, or -1 if it does not. And so just thinking to myself, this would be a very simple solution to run linearly, because we're just going to check every single value until we find the target. And if we don't find it, then we're going to run out and return -1, right? But we have to write the algorithm in log of n time, right? AKA another word for that is binary search. So let's go ahead and look at this example. So as you can see, we have a rotated array, right? And we know that it's rotated because it looks like it's rotated, right? Everything on the left of this is sorted and everything on the right of this is sorted, right? So that's a good way to explain it. It's everything on either side of the pivot is going to be sorted, right? Well, so how can we use that in our binary search to look for this target value? Well, in binary search, we're going to have a left pointer, a right pointer, and a mid pointer, right? Let's go ahead and just put this, just for example's sake, we're going to put the mid pointer here. So now that we have our mid pointer, and we know that we're on the left side of the rotated array, we know that we're on the left side, right? Because the value at the middle index is greater than the value at the left index, right? So let's just say our middle index is here. We are not on the left side of the array because the value at the middle index is not greater than the value at the left, right? So we know that we're on the left side of the rotated array, and so let's now determine where we need to search. Do we need to search to the left, or do we need to search to the right, right? Well, let's just go ahead and say our target is greater than our mid value, right? So our target is going to be greater than our mid value. Well, all values that are greater than our mid value, you'll notice, are to the right, right? Because since it's sorted and we're on the left side of this sorted array, every value that is greater than 6 is to the right, right? So since we're using binary search, we can cancel these out and we can search only these values, right? Well, what happens if our target is not greater than our middle value? Let's say our target is less than our middle value. So if our target is less than our middle value, we have two options, right? So 4 and 5 is less than 6, and 0, 1, and 2 is less than 6. Well, since this is the pivot, what we're going to do to determine whether we should search on the left side or the right side is we're going to compare our target to our left value. So if our target is less than our middle value, then that means we're going to search either these or these. If our target is also less than this value, that means we're going to search only these, right? So we're going to cancel out these values and search the right side. But if our target is greater than our left value, then we only want to search these values, right? We don't want to go this way, we want to go this way. So we're going to cancel out all of these. and only search these values. So if we're on the left side of the pivot array, if our target is greater than mid, then we're going to search the right side. If our target is less than mid, then we're going to compare the target to the left value. If the left value is greater than the target, then we're going to search the right side. If the left target is smaller than the target, then we're going to search this side, the left side. Okay, so now we're on the right side of our pivot array. So we know that we're on the right side of our pivot array because our left value is greater than our middle value. So that's how we're going to determine if we're on the left or the right side of our pivot array. So since we know we're on the right side of our pivot, how are we going to know where to go? So you'll notice if target is ever less than our middle value, then we know for a fact we're going to search the left side, right? Because everything less than the middle value is going to be on the left side of it, right? So if target is less than mid, we can cancel out these values and search the left side. Let's say our target is greater than mid. Well, this value is greater than mid and these values are greater than mid, right? So how are we going to determine where we should go? Okay, so well, similar to earlier, we're going to compare our right value to the target, right? So if our target is greater than mid, then we can either go here or here. And then we're going to compare our target to our left value. So if our target is greater than our right value, then we know that we want to search on this side. So we can cancel out these and search on the left side. If our target is greater than mid and it's less than the right value, then we do not want to search these values. We want to search these values, right? In this case, there's nothing to the right, so we'd actually end up turning -1. But the point is there's really two main cases to look for, and then sub cases depending on which side of the array we're on, right? So the first case is if we're on the left or the right side of the pivot index. And then the next case is depending on which side we're on, where you have to determine which side we should search for, right? So let's walk through this example where target equals 0, right? So our mid is here, and we know that our pivot's here, right? But I'm going to erase that because this is live, right? This is go time. Okay, so remember, our target is less than 7, right? Our target is 0, our mid value is 7, and our target is less than 7, right? So since our target is less than 7, we can search either these or we can search these. Well, which way do we go? How do we know where to go? Again, we're going to compare our target to our left value, and we compare it to our left value because we're on the left side of the pivot array, right? So once we compare our target and we find out our target is smaller than our left value, we know that everything smaller than our left value is going to be to the right of the pivot. So we can cancel out these values and search only these values, right? So now that we're here, our mid pointer will be here, our left pointer will be here, and our right pointer will be here. And this will be handled like we're on the left side of the pivot, right? Because technically our middle is greater than our left, so it'll be handled just like we're on the left side of our pivot because it's all sorted. So in this case, let's continue. So our target is less than our target is less than our middle value, so we know we're going to search right. So we can cancel these out, and then we're stuck with this value, and we're going to return the index, which is 4. And that's the correct answer. And we know that binary search, the time complexity is going to be log of n, because for every search, we're going to basically be cutting out half of the possibilities, right? So if you're not familiar with that, this is just this, every binary search is the same basically. So our left, our mid, and our right. So if we go to the right, then we're going to cancel out all of these and only search these. If we go to the left, then we're going to cancel out all of these and search all of these. So that's where log of n comes from. And we're not going to have any extra memory. So this is all we need to care about. Our time complexity is going to be log of n, which is exactly what they were looking for here. So that's pretty much it. Let's go ahead and code this up. Okay, so remember we're going to be doing binary search. So we need a left and a right pointer. Our left is going to be 0. Our right is going to be the length of the input array minus 1, which will just be the end. And then for binary search, we're going to have our while loop. So while left is less than or equal to right, we're in our while loop. And we can go ahead and if we ever break out of this, it means we are not going to find it. So we can go ahead and return -1 if we ever break out of our while loop. But while we're in our while loop, we're going to find our mid pointer. So our mid pointer is going to be left plus right divided by 2. And this in Python, this is integer division. And then we can go ahead and check if our middle value is equal to the target. So if our target equals our middle value, then we can go ahead and return mid. If not, then we're going to get into the bulk of our function. And remember, we're going to check which side of the pivot array we're on, right? So, and we're going to do that by comparing the middle value to the left value. So if our middle value is greater than or equal to our left value, we are on the left side of the pivot array, right? So left side of pivot array. Otherwise, we're on the right side of the pivot array. Okay, so remember, if we're on the left side of the pivot array, if the target is greater than our middle value, we are only going to search the right side. So if target is greater than our middle value, we're going to search the right side. So we're going to update our left pointer, right? And then there's another case if we need to search the right side. Remember, so if our target is less than our middle value, it could go left or right. So if it's less than our middle value, then we also need to check if it's less than the left value. So if target is less than nums of left, we also want to search the right side, right? Other than these two cases, we're going to search the left side. And to search the left side, we're going to update our right pointer. So our right will equal mid minus 1. And that's it. That's all we're going to do for the left side of the pivot array. So now we can go down here. So remember, if we're on the right side of the pivot array, then we know if our target is less than our middle value, then we're going to search the left side, right? We're always going to search the left side. So we're going to update our right pointer. But remember, there's another case where we could search the left side, right? So if target is greater than mid, then it could be either on the right side or the left side. So we have to compare the target to the right value. So if target is greater than nums of right, we're going to search the left side, right? Other than those two cases, we're going to search the right side. And to do that, we're going to update our left pointer. And that's it. So that's our algorithm. Let's go ahead and run it and make sure it works. And awesome, everything worked. First try. I'm actually surprised. This problem has given me problems before. So Thanks for watching. I hope y'all enjoyed it and I hope you learned something, and I'll see you on the next one.